Now we can discuss a little more about elliptical orbits. So we already learned more about ellipse. Here also it comes in E less than energy and eccentricity in between 0 and 1. Okay. If eccentricity becomes 0, the ellipse converges to a circle, right? So we have the orbit equation r is equal to r0 by 1 minus epsilon cos theta, and it have a maximum value when theta is equal to 0. When theta is equal to 0, cos theta is 1. Therefore r max is equal to r0 by 1 minus epsilon, and minimum when theta have value pi, and when theta is pi, cos pi is minus 1. Therefore r minimum is equal to r0 by 1 plus epsilon. So r max is 1 r0 by 1 minus epsilon. R minimum is equal to 1 r0 by 1 plus epsilon. Here r0 is only a scaling factor and nothing to do more. So this figure gives you the idea of r minimum. This is r minimum and this is r max. So the sum of r minimum and r max will give you the length of major axis that we call A. Okay, this is A. So A is equal to r minimum plus r maximum. So that is r0 into 1 by 1 plus epsilon plus 1 by 1 minus epsilon. So solving, you will get 2 r0 by 1 minus epsilon square. But you know what is r0? R0 is L square by mu c. Epsilon is square root of 1 plus 2el square by mu c square. Substituting the values, you are getting 2l square by mu c divided by 1 minus 1 plus 2el square by mu c square. On simplifying, we will get c by minus e. Very important. A is equal to c by minus e. So we will use this several times. So you have to remember what is A. A is the length of major axis is equal to c is the constant divided by E minus E is energy. So here we have two comments. One is A is independent of L. A is independent of L, and orbit with the same major axis have same energy. Okay, I will repeat. Independent of L. Second, orbit with the same major axis have same energy. For example, here see there are different orbits. So here there are different orbits, but every orbit have the same length of major axis. See the different shape. Okay, even though these are different in shape and having the same A value, they have same energies. Okay, that's very important point. So they have same energy. Now let us calculate the ratio R max by R minimum. These are all important while calculating some numericals. R max divided by R minimum is equal to R0 by 1 by R0 by 1 minus epsilon divided by R0 by 1 plus epsilon. That is equal to 1 plus epsilon by 1 minus epsilon. That means R max, the ratio R max by R minimum is equal to 1 plus epsilon by 1 minus epsilon. Suppose epsilon is near 0. That means our orbit is almost circular in shape. Okay. Therefore, R max, the ratio of R max by R minimum is approximately equal to 1. Okay. So this is what I say, almost circular. When epsilon is near 1, that means about 0.9 like that. So that will be an elongated ellipse. So that will be an ellipse. Epsilon is approximately equal to 0. That's going to be a circle in shape, and as approaches to the value of 1, it is almost an elongated ellipse. I will give, so what I could say is the value of epsilon determines the shape of ellipse, as I already says. Okay, let me give you some of the values of eccentricities of planets. Okay, see here, Mercury 0.206, you can see all the values here. What I can say is almost, so the Halley's comet have 0.967. See, apart from Pluto and Mercury, all other planets have an eccentricity almost equal to 0, very close to 0. See, 0.007, 0.01, 0.09, 0.04, 0.05, 0.05, 0.007, like that. So that is why we see the orbit of planets as almost circular. Okay, but the Halley's comet, it is 0.967, like that.